The day has finally come. Rhino 8 has been released, and in this video I will guide you through the top 8 features that I like in Rhino 8 and that I think everyone should investigate on their own. And how can you investigate it? Well, by downloading the free evaluation. Yes, that is true. With the new release of Rhino 8, now everyone gets the new evaluation, right? So a new free evaluation for 90 days. So anyone can download it and anyone can just check out the features themselves. With that being said, let's start with feature number 8. We'll go from bottom up. That is the dark theme of the UI. I think this is a very welcome addition, and I think this has been a long time coming, because the UI situation has been for a long time something that I was not comfortable with when working in the dark, right? The UI was just simply too bright. Now that is fixed. There's not really much to talk about it in this case, so we are just going to move on to feature number 7, which is Grasshopper 2. So if I type in G2 as my command, is going to complain and say that it's still in the work in progress phase, which is alpha in this case, and I'll just hit OK, and actually Grasshopper 2 opens up. So this is something that David Retton has been working for a while, and this is still completely, unfinished, really just the beginning of it, but something that eventually will replace Grasshopper 1. So now with Rhino 8 you do get access to Grasshopper 2. That sounded weird, but you get what I mean. One thing that I could show you, as just an example of what you can do in Grasshopper 2, I think that this is gonna be a pretty fun thing. If we just draw some sort of a region right here, like that, and reference it in here into Grasshopper as Grasshopper 2 as a curve. That is not how you curve. Come on, curve component. Zoom, zoom, zoom. Right click. Set 1. There we go. Now they're linked. I can go to the display tab, and here under scene I can choose crowd. Right? And what happens when I plug in the curve to the boundary of the crowd? Well, come on. Upside down. Okay. Flip. A crowd is generated. It's the weirdest thing. I have no idea. I mean, sure, why not? For architectural visualization and so on, that does make sense. But hey, those are the features that are going to come with fun features that are going to come with Grasshopper 2. Of course, parallel computing and so on, but those are boring things. Crowds and cars, or rather, let's go for traffic. Right? So traffic driving around a crowd of people. Anyhow, that is feature number 7. Finally, we get a taste of Grasshopper 2 and we can start experimenting with it a little bit more. Now on to feature number 6, which is the auto plane. Auto plane. So up until now, working with C-planes was a little bit of a hassle, because you would always need to reposition the C-plane, and usually if you're working with a complex shape, and usually I would do it in a C-plane, usually 3-point C-plane, and then I would select point 1, point 2, point 3, and then the C-plane is created right here, right? So now if I were to draw anything here, this shape draws on that particular C-plane. If I want to reset it, I just type in C-plane WT. C-plane world, enter, top, enter, right? So it resets. Now, here in the bottom, where it says auto C-plane per object, if I make this active, and now with Control Shift, which is the sub-object selection tool, I select any of the faces of the robot that I have here, the C-plane will be snapped, will be snapped to that face, right? Will be reoriented, which is very, very nice because then you can, you know, kind of draw some things, model out a shape, extrude the shape in that particular direction, and so on, right? Clearly, you know, this is more convenient than using 3-point C-planes all the time, especially for architectural design, right? So those are C-planes. Of course, if I right-click on this auto C-plane tool icon right here, I have the possibility to not have the C-planes sticky, meaning if this is unticked, then by default the C-plane is always world XY, well, at least in this perspective view. And then if I select this face, you can see that here the C-plane does change to fit on the surface selected or SubD patch selected. But then if I unselect, it disappears and it snaps right back to world XY. That is what sticky auto C-plane, not having sticky auto C-plane does, right? You need to keep the item selected to have the C-plane. If it's sticky, then even after you deselect something, it still holds the C-plane in that particular place, right? So that is my feature number 6, was it? Yes, that is number 6. Now let's go to feature number 5, which is a modeling tool, a push-pull tool that is introduced with this version of Rhino. So if I were to model out, let's say, let's go back to a regular C-plane. If I were to model out just a box, a red box right here, right? And I select this face and I inset. Or I can actually, let's do it this way. I select this face and I dupe border. I get the outer perimeter as a curve of this face. I offset this face inwards by, let's say, 25, something like that. I can then use push, pull command, select surfaces to push pull. I can select inside of the region of that rectangle that I drew. Remember, that was just a curve. I will actually escape out to show you. This is just a curve, right? The surface is still fully intact, right? And with the push-pull command, it does not matter because I'm selecting a region, right? So it does the math behind the hood, so to say. I just select it and I can push it in. Just like that. It's that simple. Let me show you a different thing. So for instance, if I have this edge right here and I chamfer it, chamfer edge, and I give it, sorry, I first need to say the next chamfer distance is going to be, let's go for 50, something large-ish, right? Actually more, apologies. Chamfer distance 250. There we go. And I can, of course, push-pull on this, push-pull inwards, like that. And it does all the Boolean operations, everything that I needed to do by itself. And I can still, this is, remember, the curve? I can still repeat the push-pull command, select the inner surface right here, and push-pull on it like that. As easy as it gets. Pair this up with auto C-plane, right? Where I can reposition the C-plane on here, and thus then I'm able to very easily draw circles and whatnot. Let's go for something like this. And then I push-pull again. Select inside of these regions. I believe you can select 2 of them at the same time. Yeah, absolutely you can. And you can easily push-pull through the whole shape, right? So that it actually booleans out a through hole, just like that. Such a convenient thing for 3D modeling purposes. Actually, I'm curious how will it behave if I were to, okay, we select this, so the C-plane becomes here, and I model out some sort of a rectangle real quick, or draw out a rectangle, push-pull again, select the surface inside, push it in until here, works like a charm, no issues whatsoever. I actually pushed it a little bit too close to the bottom, so now it's peeking out the Boolean difference carved into the bottom. Anyway, I guess you can see the possibilities of this tool, and yeah, this is such a welcome addition, a great tool to have. Moving on, let's reset, there we go. Moving on, was it 5? Yeah, it was 5. 4, number 4. The SubD sharpening. So up until now, let's find, let's say this element right here, I guess, or even better, I'll just make a SubD form really quick. So I'm going to pause the video just for a second, then you will see a form that I've made. 1 second. Okay, I'm ready to give an example. So sharpen or sharp tool. Up until now, when working with SubD, let me hit tab right here to get a smooth version. You would have with EMAP to get not a perfectly sharp seam, you would need to duplicate edges, right? So you can see here, 2 edges hold a seam that is not perfectly sharp, but also not perfectly smooth, not perfectly round, right? So if we look at these 3 examples right here, or they are currently identical, this one is perfectly smooth. Then to sharpen, let's say this seam, you would have 2 options. Option number 1 would be to select these edges and type in crease. You know, you would crease the object and you would get this kind of a, with EMAP, it's kind of a sharpening, right? Or maybe even better if I show it with the Arctic view. Absolutely not, that is horrible. Okay, so sharpening, right? Alternatively, just like with this robot right here, the CRT robot, you could bevel, give it only 1 segment, so that is not too much, and then create this kind of a gap right here, right? And if we press tab, we can see that, okay, sure, it's sharpened, and the control of how sharp it is can be done by changing the gap between the 2 lines that you have just beveled, right? Like this gap right here. The wider the gap, the smoother the transition, right? So the problem happens when you have so much geometry, just like here, where you kind of need that sharpening to happen, but you don't want the perfectly sharp corner, right? Everything starts getting duplicated. And if I look at the fingers and so on, like this becomes quite heavy in terms of geometry, right? The geometry becomes quite heavy, and there's quite a few edges. That was a problem, and in terms of 3D modeling, that was hell to do. So now you have sharp command. If I type in sharp, it's not even actually showing up as a suggested command, but it is there. Sharp, enter. Select interior SubD edges. Sure, I'm going to select these edges right here. Enter. And here you can see that it asks you to basically specify for the points what is the percentage of sharpness. 0 being no sharpness, 100 being fully sharp. So what we can do is we can say at the start, I select this point and I give it 100. And at the end, I select this point and I also give it 100, right? Hit enter. And now it's almost identical to the crease tool. It still shades a little bit smoother than the crease tool. It still has that smooth kind of bevel or fillet, I guess, on the edge, but it is quite a bit sharper than duplicating the edges like that, right? So that's sharpening with a constant value. You can also, let me undo that, sharp. You can also sharpen with a non-constant value, which is very, very valuable. So for instance, if I only want it to be sharp here and I want it to be smooth, completely smooth here, I can choose this point and I can specify that it should be 0. I can choose this point, I can specify that it should be 100. Right, so here it's going to be 100, this point 100, and the last point is automatically 0, has been from the start, so we're good with that. Enter, tab, and you can see now that it's perfectly smooth here, and it becomes sharper and sharper and sharper the closer you get to this segment right here. This saves so much time while working with, you know, by not needing, to work with the two edges that we had to work with before, right? It's gonna be so much quicker, because technically the way that I'm doing it right now here, it is going to be pretty pretty close in terms of the behavior. If I press tab, let's get rid of the crease that's just in the way. Crease is bad, don't use crease. I mean, it's there, it's close, but this requires two edges, while this one can be handled with only one. That's a big deal. Okay, so that's sharp tool. Then let's move on to feature number 3, which is going to be a very, very quick one, very, very short one, and very, very hard to also showcase, but this was gonna be a trust me bro moment. The speed of the viewport, the responsiveness or the performance of the viewport when switching between different views and different like types of preview is much faster. Even very interactive snaps into rendering much faster, but the biggest improvement in my opinion is with snapping and with just how quickly meshes are refreshed, right? In terms of render times, I mean, I'm recording a video and it's let's just give it something to work on. It's really not that bad, right? Really not that bad. Just let it run for a few more instances. 36, 37, 38, 40 seconds, and we have a usable image. So that's just the render times, but again, in terms of the viewport performance, the main thing is indeed just the how fast things snap, how fast things move, and how fast the camera is able to refresh the shapes that are being showcased. Okay, now let's move on to was it 2? Feature number 2. If I type in Grasshopper while Grasshopper is loading, it's actually loaded in really fast because I have already loaded it in, but Grasshopper has a whole new tab, well, not a new tab, but a renamed tab called Rhino. And in this tab, you have the content subtab. Of course, I could kind of start talking about all of these things and kind of explaining every single one, but I think we don't have the time. I will just show you the most important thing for me, that I find most important. Now, Grasshopper is able to import external files into itself, read external Rhino files. You could have done that before with certain plugins, but now you can do that just with Grasshopper itself. So if I choose import content node right here, it asks me for a file path. I can right click, set one existing file, and I can just navigate to, we did the Nakagen Capsule Tower project recently. Let's open that one up. So Nakagen, get the minus, hit open. All right. And all I need to do is just hit import. Give it a second. It imported, and now the outputs are basically all of the model transforms, the model transform of the current model, all of the objects, all of the layers that are being used, so that the objects, they don't come in just as a mesh or a B-rep, they also come in with layers associated with them in their metadata. That's important, because if I do, let's do, we could do a mesh preview, but let's not. Instead, let's just enable this preview so that you can see better. There you go. That's the whole damn Nakagen capsule, right? And I can show you the benefit of it or the strength of it, because everything comes in, like all of the data, all of the line times, hatches, even the materials, they also are here. Meaning that if I were to bake this content cache, that's the bake button now, objects, connect that, and just hit update, it will bake out the whole project for us. Just give it a second. There we go. Now I can hide this. And if I were to, let me just hide the SubD and hide the meshes by parent, VIP, and rotation. There we go. So it came in all in their own layers, right? So the layers transferred, and not just the layers, but also the materials transferred. If I just type in, or not type in, let's go for V-Ray Interactive again. Let's just start rendering it. And you will see that every single object that had layers in the original file will have layers in this file as well. With that being said, I do need to turn on the sunlight. Give me a second. Nope, that's the wrong direction. Okay, that's I think good enough. Let's now zoom in here, change the camera angle to something a little bit more reasonable, like 30 mil. And I can finally, I'm sorry for the wait, but I can finally show you that, you know, the refrigerator is indeed metal. And if we wait just a little bit longer, you will see that there are actual, oh, ew, the noise, the denoiser is just destroying the image. But there are actually numbering of the textures on these kind of shelves and so on right here. So those things are important, and those things will help out quite a bit when you have a really heavy scene that you need to deal with. You can now separate it into separate parts, into separate entities, and reassemble them through the use of Grasshopper. I think that's quite nice. Oh yeah, and also of course the hatches and the curves, the text, everything transfers. Keep in mind this is a Rhino 7 file as well, not Rhino 8. that was imported. Okay, let's undo this real quick. Undo multiple. Let's just find layer expander, Grasshopper solution. So we are going to undo it until the Grasshopper solution, just like that. Okay. Now we are back to our, or we're moving forward, sorry, to our first place, to feature number 1. And that is called shrink wrap. Surprise, surprise. Shrink wrap is a tool that makes any geometry, any messed up geometry that you might have, into 3D printable solid mesh. And then with additional tools, you can convert it into SubD with quad remesh and so on. But the main purpose is watertight solid mesh. Perfect for the FEA analysis, the stress analysis and so on, or wind analysis, or for 3D printing. And for us architects, 3D printing is the key place where this is going to be used. So if let me hide SubD, and this time let's just look at the NURBS version of this, and let's just look at the arm. Let's say I want to 3D print out this this part, right? Isolate this part of the hand. Before this would have been quite nasty, trying to get all of these elements to either Boolean union, or if you have them as open meshes, trying to close the meshes and so on. Especially considering that, every single part right here is just, an entity on its own. Like they are separate objects. Now, if I select all of this and I type in shrink wrap, if I can type, there we go, shrink wrap, and I specify what's my edge length, basically what's the resolution at which I work. That's going to be, I have no idea what's the resolution here. I'm gonna trust it with 3.62, we'll see. I'll hit preview, I'll let it think. Height input objects, and there is a mesh with this particular resolution, right? At this particular resolution wrapped around my hand. Does not look that great, right? Because the resolution is too high. So we're just going to tone it down a bit. So let's go for 2. Target edge length 2. Starts looking a little bit better. 1. Even better. Now we're getting a little bit more of a resolution here. 0.5. Excellent. 0.5 seems to be good enough for, anything related to 3D printing. I mean, unless you're printing in resin and this is a pretty big model, then of course you would need more. But besides that, I think this is good. So now I hit OK, I accept. I move this mesh to the side, and we can actually change this to Arctic view to just see any kind of visual difference. And of course there are going to be visual differences. I mean, this is everything here is going to be a little bit softer, a little bit more filleted, but come on, it's pretty close. And knowing that it's always going to be closed, think of the Revit models that you import, think of, architectural models, how fast it is to actually make things 3D printable now. This is so good. This is such a time saver. It's a great tool. Also, just to kind of prove a point on how messed up the geometry can be, and that it's still going to work, I'm going to make a box right here. And when I say here, I mean, let's say from this point on, just like a box that is sticking out, all kind of messy, just going through. And let's, for the sake of argument, let's make the box open. opened on both ends, right? So it's really bad. Another sake of argument, sorry, I know. Boolean difference. Let's make a hole in the hand first and then open up the box. Oh, it failed. Or did it not? Oh, it partially failed. Oh, that's perfect. Actually, that's perfect because now I can delete away some of the faces. Question mark. At least that one, right? Anyway, let's shrink wrap this. So I'm selecting this, shrink wrap. I wonder why that didn't work. Doesn't matter. 0.5. Preview. Hide input objects. Wait for it to calculate. We get a form, right? And notice how the box right here is not calculated. And you might say, oh no, so that means this does not work. You know, that there's no way to shrink wrap super thin objects. Well, you can either inflate vertices, but that's a little bit iffy, or you can create surfaces. So I'm just going to make a surface right here. And just to prove a point, I'm going to make a surface that is a little bit out there, you know, but a surface that kind of intersects with the box by capping it, just like that. And like that here. Shrink wrap this again. Oh. Preview. It's going. Right? And now we have ourselves a box here, because it does calculate the volume. It does not need things to be capped, closed, and so on. As long as the amalgam of the geometry, all of the geometry is in the same place and kinda envelopes a volume, it will shrink wrap on it very nicely. And it is going to read the new volume quite perfectly with nice seams and whatnot, right? So now we have another version of this here. The box with the end caps that are, you know, just surfaces that are slapped on there. So imagine 3D scanned data. 3D scanning of data, and you have windows, and the windows are just holes. After 3D scanning, you just add surfaces into the holes. Suddenly you can shrink wrap the whole damn thing and 3D print it. Super nice. Okay, so that is shrink wrap. In total, we have, you know, we're done. That's 8 features. I personally will migrate to Rhino 8 in a way that every new project that I do, I will be doing in Rhino 8. Every old project that is ongoing with Rhino 7, I will stay with Rhino 7. I think that's, you know, the most stable way to go about this. But is Rhino 8 worth the upgrade? For me, it absolutely is. Because the shrink wrap tool, the push-pull tool, the sharp, the SubD sharp tool, only like these 3 are already enough for me to convince me to upgrade, right? But for you, it might be a different story. So again, just go in here, go into rhino3d.com/download, get the 90-day free trial of Rhino 8, play around, see if that works for you. If it does, hey, upgrade, I guess. Okay, I'll see you in the next one. Bye.